Hello everyone, today we are going to start our new lesson, ionic bonding. Before describing this topic, I would like to give a brief description of bonding. What is bonding and why do metals or why do elements they form bonding? So bonding is actually formed whenever electrons transfer takes place between atoms, or whenever electrons are being shared between atoms. Okay, so this is bonding is actually the reason for chemical reaction. Okay, because of bonding many chemical reaction can occur. Okay, chemical reactions occur because of the bonding. So why this bonding form, or what is the need for bonding? Okay, the need for bonding is that you've heard, or you might have heard about Octet Rule. Okay, Octet Rule. Okay, it says that an atom always tend to complete its valence shell by having 8 electrons. Okay, all the atoms, they need to complete their valence shell or their last shell by having 8 electrons. They do this by either sharing electrons or either transfer of electrons. So according to this Octet Rule, octet means 8. This Octet Rule, on the principle of this rule, on the basis of this rule, atoms, they either share electrons or they either transfer. They either give electrons or they either take electrons. Okay, keep in mind that electrons, okay, the electrons specify the chemical reaction. Okay, chemical reactions do occur because of the presence of electrons. Okay, neutrons and protons, they do not take part in the chemical reaction. Okay, sorry, no charge. So the basis for chemical reaction, or the chemical reaction, occur because of the electrons. And which electrons? Which are present in the last shell. This is, okay, those electrons which are present in the last shell, they took part in the chemical reaction. Okay, so Octet Rule, on the basis of this Octet Rule, the atoms, they want to have a complete valence shell. Complete. When it will become complete, it will become complete if they have 8 electrons. Okay, all the atoms. So that's why the atoms, noble gases, okay, the noble gases like helium, neon, argon, krypton, okay, they are inactive. Okay, they are inactive. Why they are inactive? Because their last shell is complete. They don't need any further chemical reaction. Okay, their last shell is complete. They do not need to complete their valence shell because all of these atoms present in the 8A group. Okay, 8A group of the periodic table, they have complete valence shell, they have complete last shell, and that's why they do not require to complete their outermost shell, and that's why they do not need any chemical reaction. Okay, that's why they are inactive. They are called inert gas because of their inactive property. And why they are inactive? Because of the presence of complete valence shell. So this is Octet Rule. Another rule which is also specified, which is similar to that of Octet Rule, is the Duplet Rule. Okay, Duplet Rule, it says that atoms tends to complete valence shell. Valence shell, also called last shell. The last shell is called valence shell, by having 2 electrons. Okay, so for this duplet rule is only applicable for hydrogen and helium. Okay, hydrogen have 1 electron and helium have 2 electron. Okay, helium have 2 electrons, so it is complete, it is inactive. They do not need it. This helium atom does not need any further chemical reaction. It is inactive, it is inert. Okay, and that's why it is called noble gas, because of its unreactive property, while hydrogen is very reactive. Why? Because it have only 1 electron, and on the basis of this duplet rule, hydrogen will do any sort of chemical reaction. Hydrogen will tend to complete its outermost shell, which have only hydrogen have 1 shell, and it will tend to complete its outermost shell by having an extra electron, either through transfer or through sharing. So on the basis of these 2 rules, bonding, okay, chemical bonding, on the basis of this 2 rule, chemical bonding, okay, which can be defined an association, okay, between atoms. It is basically of 2 types, that is ionic bonding and covalent bonding. Ionic bonding, type of chemical bonding in which an atom either takes an electron or gives an electron to have a complete valence shell. By complete valence shell we mean to have 8 electron in valence shell. Whenever an atom have 8 electron in its outermost shell, it is called a complete valence shell. Okay, that last shell may be 6, 5, or doesn't matter. Okay, so the last shell must have 8 electrons. And keep in mind that ionic bonding occurs between metals and non-metals. Ionic bonding occurs between metals and non-metals. For example, sodium chloride. Sodium is metal and chlorine is minus. Okay, or we can say that it occurs between positive and negative ions. Okay, is that clear? So this is chemical ionic bonding. Another name for for this ionic bonding is called electrovalent. This ionic bonding also called electrovalent bond. Why it is called electrovalent? Because the last electron means electrons, valent means valence shell. Okay, why electrovalent? Because last shell electrons are involved. Last shell electrons are being transferred between atoms. Is that clear? And due to this electrons transfer, okay, due to this what happens? Strong electrostatic force of attraction. Strong electrostatic force of attraction occurs between negative and positive ions. Okay, is that clear? So strong electrostatic force of attraction. But electrostatic force of attraction is the force of attraction which is present between positive ions and negative ions. Okay, so the force of attraction which is present between positive charge and negative charge, this is called electrostatic force of attraction. So this ionic bond, those compounds that have ionic bonding, they have strong electrostatic force of attraction, and because of this strong electrostatic force of attraction, the compounds having ionic bonding, they are solid and they have high melting and boiling point, and most of the time they are solid, and it is very difficult to break ionic compounds. It is very difficult. Okay, so this is overall concept. Now let's draw some examples of 7 electrons. In the same way, if we see chlorine 17 electrons, 2, 8, 7. Let's draw the cross structure. Okay. I will draw the cross shape in order to specify the electrons of both opposite atoms, and the final have 7 electrons. 6, 7. Okay. Now what happens if you see chlorine have 7 electrons and their sodium have 1 electron in the outermost shell? So what will happen? Logically, sodium cannot have that much amount of energy in order to pick up 7 electrons. Sodium does not have that amount of energy. So what will we do? So what the sodium will do? Sodium will expel electron to the chlorine, and in the same way chlorine have 7 electron in the last shell. So chlorine does not have that amount of energy in order to remove all the 7 electron and give it to sodium. So sodium will logically will acquire an electron from other atom. It have that amount of energy in only to take an electron from another atom. Is that clear? So what will happen? That this sodium will give electron to the chlorine, and the last shell of chlorine will get fulfilled, and as a result sodium will lose one outermost shell. So if I draw the structure of sodium after bond formation, sodium will have only one shell. Okay, sodium will have only one shell because the last shell is being totally removed. The last shell does not remain, and as a result this is the chlorine having 3 shells and the last shell having complete 8 electrons. Okay, is that clear? So now chlorine have 3 shells but sodium have 2 shells. Okay, so the last shell is no more. In the same way we can write this. Keep in mind we will only consider the last shell electrons. So whenever we are drawing or whenever we are drawing the ionic bonding, okay, we will only consider the last shell. So we will skip the inner shell electrons and the inner shells. Okay, we will skip it because the last shell electrons are involved in any sort of chemical reaction. We will not consider the inner shells. We will not consider them. So the inner shell electrons will not be considered at any, because inner shell electrons, they are not involved in any sort of chemical reaction. So it will remain as it is. Okay, so sodium last shell is no more, and it will acquire a positive charge, and negative charge will appear on the chlorine atom because chlorine have gained 1 extra electron, but still chlorine have 17 proton and 18 electrons now, and sodium have 10 electrons but 11 protons. Is that clear? In this way we can also write chemical bonding. After bond formation we can write sodium plus and chlorine will be written in this way. Those shell electrons are being considered. Sorry for that. Okay, 1 electron from sodium. Is that clear? So in the same way you can write the same. If you see potassium fluoride, potassium atomic number is 19 and fluorine is 9. Okay, so it means that potassium have 19 electrons. The electronic configuration is 2881 and that of fluorine is 27. If you see, if we draw, as I told you earlier, that we will only consider the last shell. So this is fluorine. The last shell have only 1 electron. Okay, and potassium, and here fluorine, in the last shell it have 7 electrons. So we'll draw the 7 electrons. Okay, so what will happen, this electron is being transferred completely to fluorine. Okay, because potassium does not have that amount of energy to gain 8 electrons at a time. It will definitely give 1 electron. That is the 1 electron which is present in the last shell. And as a result, what will happen? Potassium will have positive charge, and fluorine will have extra electron from potassium. Eight electrons are being fulfilled. Okay, so this is potassium fluoride. Okay, positive charge on potassium and negative charge on non-metal fluorine. In the same way, for magnesium chloride. Okay, magnesium chloride, its formula is MgCl2. Okay, now here 1 magnesium and 2 chlorines are there. So if we see the magnesium, first we will write the atomic number, that is 12, and electronic configuration would be 2, 8, 2. And chlorine, atomic number is 17, electronic configuration is 2, 8 and 7. So in the last shell of magnesium, 2 electrons are present. Okay, but chlorine, 2 chlorine atoms are there. So chlorine last shell have 7 electrons. Each chlorine. Seven, 4, 5, 6 and 7. Now this dot and cross diagram. So this magnesium will transfer 1 electron to 1 chlorine atom and another electron to another chlorine atom. So in the same way, what will happen, that magnesium final last shell will no more there will no last shell of magnesium, there will be no more shell of magnesium, and as a result it will develop positive charge, and chlorine atoms will have complete outermost shell. Is that clear? So is that clear? So this way you can write and you can practice the ionic bonding of compounds. Let's suppose there is another example, calcium oxide. Calcium oxide, okay. Calcium oxide. CaO. Okay, now calcium, as we know that its atomic number is 20, electronic configuration is 2, 8, 8, 2. On the other hand, oxygen atomic number is 8, electronic configuration is 2, 6. Electronic configuration of 2 in the first shell and 6 electrons in the last shell of oxygen atom. So in this case, calcium have four shells, and these are the number of respective electrons in their shells. So if I draw the last shell of calcium, only last shell of calcium have 2 electrons, okay, and last shell of oxygen atom have 6 electrons. Okay, so definitely what will happen, that calcium will transfer both its electron to oxygen atom. Why oxygen atom? Because oxygen here is 6 electron and calcium is 2 electrons are present. So in order to fulfill the outermost shell, calcium will give 2 electron. Calcium have that much amount of energy only to give 2 electron to oxygen atom, and oxygen have 6 electrons. Large number of electron, 6 is greater number, so definitely logically oxygen will have that amount of energy to take 2 electrons in order to fulfill its outermost shell. When it will become fulfilled, when its number of electrons reaches up to 8 number. Is that clear? So as a result, what will happen, that calcium donated 2 electron to oxygen. Now as a result, both atoms, this is calcium will have no more shell, the outermost shell of calcium will be no more, and as a result this oxygen, it will have you have 2 electrons extra. Now here the atomic number of calcium is 18. Atomic number of calcium is 18 because it has given 2 electrons, and here atomic number of oxygen is 10. But proton number is 8 protons, and here 20 protons. Number of proton does not change. Okay, so keep in mind, chemical reaction only outermost shell electrons take place. Is that clear? So this was the example for calcium oxide. Okay, so in other examples you can also practice the example like lithium chloride. Okay, the lithium chloride and magnesium fluoride. Okay, properties of ionic compounds. They are the foremost property is that they are solid at room temperature. At room temperature. Why they are solid at room temperature? Because these compounds have, because of presence of strong electrostatic force of attraction between atoms. Is that clear? They are solid at room temperature, and that's why they are solid, because they have strong electrostatic force of attraction. And 2 is that they are they have high, because of this strong electrostatic force of attraction, they have high melting point and boiling point. Third one is that they are hard. Okay, they are hard. Why they are hard? Because of, again, this force of attraction. Okay, and keep in mind that number 4 is that they are soluble in water. Okay, these compounds, they are soluble in water. For example, sodium chloride, for example, sulfuric acid. Okay, for example, potassium chloride. All of these, they are soluble in water. Why they are soluble in water? Because all the ionic compounds, they are soluble in water. Why water? Because water have itself hydrogen bond is present, and we will discuss it later on. Number 5th one is that they are good conductors. Ionic compounds are good conductors. Ionic compounds are good conductors at molten state or in solution form. Is that clear? Means that when I convert sodium chloride, solid sodium chloride, into liquid state, means that if I heat sodium chloride, if I give that much amount of heat to sodium chloride that it's changed into liquid state, then it will be able to conduct electricity. Or if I dissolve solid sodium chloride in water, okay, then that solution will be able to conduct electricity. But keep in mind that solid ionic compound, okay, solid ionic compounds, they do not conduct electricity. Solid ionic compounds do not conduct electricity. Why they do not conduct electricity? Because electrons are held fixed in their positions. Electrons are held fixed in their positions. Is that clear? The electrons, they cannot move. Strong electrostatic force of attraction is present between the atoms, and electrons are held fixed in their position. The electrons cannot move. So that's why electricity cannot be passed. So, and most of the ionic compounds, when they are solid, they are in the form of crystals. They have a definite shape. Okay, ionic compounds do exist in the form of crystal shape. Okay, like sodium chloride, all the salts, they are ionic compounds. Okay, all salts, they are ionic compounds and they have crystalline shape. For example, cesium chloride, okay, cesium chloride have a very unique shape, and it have each cesium, in which each cesium is surrounded by 8 electrons. Okay, so each cesium is surrounded by 8 chlorine atoms. In the same case, each chlorine is surrounded by 8 cesium atoms. This type of shape gives a body-centered cubic structure. Body-centered cubic structure. We call this type of structure as body-centered cubic structure, in which each positive ion is surrounded by 8 negative ion, and each negative ion is surrounded by 8 positive ions. Is that clear? And the example is sodium chloride, which is given in your book. Is that clear? So keep in mind that ionic compounds, they do exist in crystal shape. Okay, crystal means, by crystal we mean that each the positive and negative ions, they are arranged in a very proper shape. Okay, whenever we are talking about crystal, it means that the particles, okay, the particles, the atoms, they have a very proper shape. Okay, they have, for example, like sodium chloride. This is the shape of sodium chloride. Okay, so each particles, they are held fixed in their position. Each atom they have fixed position. Okay, this is a cubic crystal, and this is the crystal of the sodium chloride. Is that clear? So each element is surrounded by positive ion, each positive ion is surrounded by negative ion, and each negative ion in turn is surrounded by positive ion. And this in turn give a very specific shape. So whenever we are talking about crystal means that the atoms have specific shape. Okay, so the atoms have specific shape and they have specific position. They do not change their position. Is that clear? So here, because of this certain positions, the electrons which are present in the last shell of the positive or negative ions, they are held fixed in their position. The electrons cannot move. So whenever I pass electricity from any crystal, okay, whenever I pass electricity from any crystal, what will happen? That the electrons which are present in the outermost shell, okay, they will not move. Why they will not move? Because they are held strongly of the electrostatic force of attraction. Okay, the strong electrostatic force of attraction will hold the electrons of each atom in their fixed position. So whenever we pass electricity, electrons cannot move. As a result, we will say that ionic compounds, when they are in crystal, when they are in solid crystal shape, they cannot conduct electricity. They cannot conduct electricity because of the static electrons. The electrons are present in their fixed position. Is that clear? So this is all about ionic bonding. Ionic bonding is a very unique type of bonding, and it is the strongest type of bonding. Strongest. Okay. All the compounds having ionic bonding, they are solid at room temperature and they have very high melting and boiling points. So I hope that you have understood the lecture.